and then you have some, hopefully, time for open mic. So that's all that we have.
Okay.
And we're ready.
Thank you. I've been writing the thank yous now. Thank you. Software. So
Sure.
I guess we're going second.
Yeah.
Get started.
Yep.
Hello everyone, let's get started. Welcome to the Joint Ops area and OPSAWG meeting. The note well, please make sure you understand those important legal issues. Basically, all your contributions need to follow the IETF rules. And firstly, welcome to the OPSAWG. It's chaired by Tianran and Joe. And the blue sheet is circulating. Please fill in your name so that we can get the room with right size next time. And before we can really start, we need a JavaScriber.
Jabber.
Yeah, is there any volunteer?
Someone on Jabber. I'm on, but someone else. Chris, Jabber. Yeah, that was my problem. The notes taker.
We're not. We can use the video record for the minute. Oh, that's great.
So if the past two meetings I've done transcription from the YouTube, it's worked, but I do recommend anyone who can join the Etherpad, the link's there. It really helps if you have something that you want to make sure is captured in the minutes, or that you can clarify some things. Please also, when you're presenting or when you come to the mic for comments, make sure to say your name so we can record that. But we would appreciate if anyone can contribute to the Etherpad notes, and anyone who can sign into Jabber. I'm on as well, but we would, thank you very much. So we have now relays for Jabber. Thanks.
Great. And here's the working group status. Right now, we have 6 active working group documents. We newly adopted 2 drafts before this meeting, and they are the L3NM and the IEM Model Automation Framework. Later, authors will introduce both drafts, and all of the working group drafts are very readable, and we welcome your review and comment. Here is the agenda. We can start from the working group document. Is there any question? Okay, let's start from the first one. Is there a remote?
Yeah, first up we have Oscar on remote.
Hi guys.
Perfect.
Hi. Good morning. Can you hear me correctly?
We can.
Okay, perfect. So I'm getting used to this remote presentation, but I prefer to be in person. So, okay, so let's get started. So, thank you very much. So we are gonna present today the Layer 3 VPN Network Jam model. So now it's a working group document. So please go to the next slide. So just we'll quickly introduce the motivation just for background purposes, and then we'll go into the meat into what are the updates in this new version. Explain clearly what is the hierarchy, what is the relation between L3NM and L3SM, and mainly the open issues where the feedback from the working group is welcome, and the next steps. So please go on, next slide. So first of all, the motivation of the work. So what were the requirements? So basically, the requirements was to be able to manage L3 VPNs, and that in order to help the automation, we wanted a YAM module to be able to be used from a network controller, so it could interact with a piece doing the service orchestration, either be a human network operator that interacts with the client, or it is an automatic piece of software that interacts with the client. So the existing work, the L3SM, works perfectly fine to interact with the customers. Let's say it takes all the requirements from the customers, but does not speak or does not have notions of the internals of the operator network. So here, this is why we propose this L3NM and the YAM module to manage the L3 VPN services in a service provider network, and includes information also of some of the logical resources, for example, optionally, so for example, like artists and artists. And here we try to remove all customer-related information that that piece will remain at the OSS or BSS layer, and we care about really the network layer. So please go on the next slide. So the document is now is a working group document. So first, new things in this work, we welcome new contributors. So Meda and Stefan joined the work. So also they both bring a lot of expertise from L3 VPN management and from the work from L3SM. So they provided very good inputs and help to clarify the relation between the models and help in the refining and the containers. Also, the first thing was to polish all the editorial issues. So there was a good review by Tom Petch, which we tried to fix all the editorial issues. Also, as suggested by the working group chairs, we added the implementation status. So here you have the implementation status section with 3 known implementations. There might be more out there, but at least 3 that I am aware that are documented. In this version, of course, the YAM model is outdated, and the main change is that we moved from the more science-centric view that was inherited from L3SM to a pure network-centric view. Okay, so it is the services for the network. So also we did, as we started mainly from the requirements from the L3SM, we now did the prune and take out all the customer-related parameters that are not necessary, and all the unused containers were stripped out. And so here, a lot of thanks to Stefan Litowski, that he helped us a lot to work through this through the YAM model. Also, we added some example section to help to understand how the model can be used. So here in this first version, we just started with a very simple but widely used example in service provider. So it is the L3 VPN for the 4G service provisioning. For the mobile backhaul. It's a very simple use case. So in the future versions, we'll include more complex examples. Also, we refined and clarified the terminology. So in order to avoid misunderstandings and to help the readers of the document understand correctly what we are referring to in the document, we revisited all the terminology section. Also, there were some minor additions in the routing protocols part. So I think there was the process ID in OSPF was missing, so we added it. Also, the big change in the document is the description of the YAM model itself. So here we have extended all the description so people can understand the YAM model, and the implementers and users of the model can understand it, and we can avoid ambiguities. Also, we added a section with the relation with other young models, so which are the other young models that have relation to this one. And we have added the security section with the potential threats, for example, from malicious clients or from unauthorized clients, and the reference updated and reorganized. Okay, so please go on the next slide. So as said, the first big change is the just get away from the sites. So here we don't, the sites are the customer sites. So here we are, what we want to deploy the services from the PE. So that site information we no longer need it. That is already being processed and decided to which points to enter the network. So here the main container are the VPN service and the VPN profiles. So the the VPN service contains VPN nodes, which are the abstractions that point that are like the common set of policies that applied to a network node. And within the VPN node, you have the VPN network accesses that are the points where the traffic really comes into the VPN. And there we add the L2 parameters, the IP information, or for example, the pseudo wire termination. So basically, this is the new hierarchy. So please, next slide. So then relation with the L3NM scope is from the PEs, from P to P, and we leave the L3NM scope will be from the sites and the bidders. So here you can see clearly what will be the scope and view of both models. So please, next slide. So here, this is just an example for the 4G VPN provisioning. So here, what we want is a L3 VPN service that connects the node B with the platforms. So here, what we typically need to create is a set of VPNs to connect, for example, to the security gateway. So there are several platforms that we need to connect to the node B, and they are all done by this L3 VPN. So here, basically, the service in L3NM will be modeled as two VPN nodes with one VPN network access in each one. One VPN network access facing the node B and one VPN node access facing the platform. So here, in the example, you would see how a VPN node would be represented. Okay, so both the details, you have them in the draft. So we can move forward. Next slide, please. So here, continuing with the example, here this is how we would fill also the VPN network access information. So this is how we would model the other relevant part of the document. So the VPN node and the VPN network access. So here in this example, as in a simple example, the VPN node maps clearly into a physical PE, but as mentioned, the VPN node is an abstraction. So here, if you are using some form of abstract topology, you could map that abstract node could be further expanded into multiple nodes. So then the controller will decide where to exactly to place the VRFs. So it is not always a one-to-one mapping between VPN node and VRF. Okay, so but in basic example, in simple example like this, it will be a one-to-one mapping. So please go on. So here, in the next slide, please. Okay, so here the open issues, that this is where we want to get the the feedback from the working group is the one open issue is the auto assignment of the resources. So here the RT and RD auto assignment. So here we have several scenarios. So one of them is, okay, you leave the network controller to auto assign these logical resources. Okay, you please choose for me the RT and RD. Other is, for example, for multi-domain scenarios or for scenarios where you have these resources outside, you want to explicitly assign RTs and RDs. And also there are other scenarios where the network where we don't want no RT and RD to be assigned. There are some cases of some simple VPNs that we don't want that assignment. So here what happens now in the current version of the draft, the RT and RD are optional. So the assumption is that if you don't fill them, they will be assigned by the controller and you can treat them later. So the question to the working group is whether, okay, do we need an auto assignment flag to indicate that these resources, these values must be filled, or it is redundant? In Yang, it is already implied. So can we assume that if an optional parameter is not filled, it must be calculated by the server? Okay, so this is an open question. So please go to the next slide to continue with the open issues. So here there are some open issues that we need to clarify with the rest of authors and working group. Is if the extranet VPNs for L3SM are not needed in L3NM, they can just be mapped into import export policies. Review the VPN profiles containers. So far we have found the QoS profile useful. The rest of them not, but as they are available in L3SM, we'll need to check them. We need to review the multicast. Now the requirements are directly mapped. And we have a couple of open issues, the relation with other modules. For example, with the network topology. So currently a VPN node has the NID, the network element ID, that is used to identify the network node in which the VPN node is required. So here, one possibility is to add a leaf ref in a VPN node to a node in an IETF network module. So then it will be much direct, but it will require the model to use together with an IETF network module. So the question to the working group is, okay, it is worth to adding these cross relations to other, do we make it mandatory, or if it will be a choice between, okay, you provide an ID, or is a leaf ref to a network topology. And finally, the port identification in the VPN network access, that here we might also need to add a reference to a topology, to the UNI interface, also to make this relation unambiguous. The problem is that current topology modules do not expose this UNI interface. So for that, we have submitted a draft. So I think with this, go to the next slide. And I think it's we finish with the next step. So can you go to the next slide, please, and we finish. So we want to ask you to review the current version of the document, implement some feedback, and work on the open issues. And we're going to extend this work also to L2 VPNs and create a topology model with UNI interfaces to attach the VPN network accesses, which is a work that you have also to review. So thank you very much. And if you have any question.
Comments for Oscar?
Robin from Huawei. So can I previous slides for these open questions? Previous slides. Okay. So here, in fact, from my point of view, we have implemented such a service model like this one. From our point is from the user side, they don't want to involve too much in the details such as RT/RD. Yeah, so I think the auto assign should be a default method. But to be honest, some days because the network operators, they are transited from the traditional network management way to the SDN based way. So they still has some the concern about the RTRD cannot be explicitly designated. So from my point of view, I think is auto assign can be a default one, and also that it can also provide the optional to assign the RTRD explicitly. Yeah, so that's my personal opinion.
Thank you.
Ignas Bogdanas speaking without an AD hat and as an operator. In most of the deployments that I have seen, RTs and RDs are strictly controlled. And that is coming from a source of truth, which is much more related to a lot of other parameters than just networking. Making it as a default photo assignment will directly clash with a lot of existing deployments. Yes, that option is needed, but that definitely doesn't need to be the default one.
So my main question is how to make that auto assignment. So if make add a flag in the model to explicitly say auto assignment, or just leaving blank will mean you want it auto assigned. Okay, that is our main doubt on how to do it. Thank you.
Yeah, Jim from Huawei, one of the contributors for L3NM. Actually, I have no strong preference for either one. I think if I can live with kind of default behavior, but if it is default behavior, I think it is still need to specify in the document clearly. Yeah.
Thank you.
Thank you, Oscar. To the working group, please read and comment on lists to his to the author's open items. Again, Oscar, thank you. I think we've said it before. It's great to see operators come and present this work here. I have a comment for you, but I will send it to the mailing list because we're running a few minutes behind. So thank you very much again for your remote presentation.
Thanks to you guys, and see you in the IETF.
And next up, we have, I believe, Chin, you're presenting.
Good morning, everyone. My name is Qin Wu from Huawei. I like to present this young data model framework draft. So apologize actually for one of the calls. Actually, the name actually is correct, but the affiliation is not correct. So sorry about that. Actually, I will fix this. Actually, we have a bunch of the author, and because the limit of the author number on the front page, so we move some author to the contributor. So the draft actually we changed the name because we have some discussion with chair and on the list because the draft name seems a little bit lazy. So we try to fix this, and so now we have this name still very long. So what is this draft about actually? When we prepare this draft, we were asked by many operator service provider. So you have so many young data model. How you put this model together to provide end-to-end solution? How to deploy this kind of model? How to integrate this model? So this motivated us to write this document. We really want to document the young model architecture more from the service provider perspective, based on service provider input, and try to give the guidelines for operator to see how to glue the model together, how to integrate the young data model. In addition, for this kind of architecture, actually is service-oriented architecture. So we may support various different services, layer 3 service, layer 2, maybe TE service. So different service has different functionality. So we try to do is identify the common functionality and common concept. So one of the example, actually, for layer 3 service or T service, you may support different functionality, maybe VPN or VT, but this kind of functionality can be supported by different underlying technology. For example, MPLS, GIE, and pseudowire, etc. actually. So last, we really want to give several examples to show how this functionality can be used in such kind of use cases. So this is the current status of this draft. This draft has just been adopted before this meeting, and actually we made a lot of changes based on the last meeting discussion, and try to address the comments raised in the last meeting. The one important issue is we try to document all the IETF model in the previous version. Seems to give a survey for this kind of IETF young model standardization status. We think it's not appropriate. So that's why we move this kind of IETF young model survey to the appendix. And another one is in the previous version, we mixed how the model is discovered from with how the model is integrated. So we try to clarify this and separate these two things. In addition, actually, the draft that try to generate this kind of architecture concept to cover the common functionality and concept. One of the concepts actually is the model layer and the representation. We will discuss in the next slides. So, what is the important concept? I think it is this model layering and the model representation. So you may abstract the service requirements from the top. You may abstract the network infrastructure technology in the underlying from the bottom. So usually you will classify the model into service layer and device level. But also in the middle, you need to schedule the resource to meet the requirements, to schedule resource to try to adapt to the network changes. So the network level is very crucial, important, and it will tell you where you can get this resource, how to allocate this kind of resource. One of the examples is you may figure out how to select the VPN attachment point, maybe the P. You may need to decide whether I reuse existing VRF or I need to create a new VRF, whether I need to allocate a new port. So we here give an example actually. In a service level, actually, from customer perspective, they don't care what technology you are using, what kind of resource you are allocated. So usually they will request a VPN service to describe like, I want to have 3 VPN sites. I want these 3 VPN sites interconnect with each other. I want to request a connectivity between the site with some bandwidth requirements, latency requirements. But drill down to the network level, actually, you need to figure out where you can get these resources, how to allocate this kind of resource. So in the network layer, controller need to consider how to create a VPN instance, how to create a network access to hook into the attachment point, and also you hook into this VPN instance. And in the device level, you really need to decompose the network level configuration into device level configuration. For example, you want to enable BGP or enable MPLS in the device. You really want to activate some feature within the device. So you can rely on device level model to do that. So that's the concept of module layer and representation. So this is architecture overview for young data model automation. Actually, there are several common functionality within this architecture. This architecture really classified into the device level, network level, service level. The commonality between the service level and the network level, you will support the service life cycle. for example, service creation, modification, and service optimization. When you get the network set up, you really want to optimize the service based on the network performance. At last, you really need to consider how to, break down this kind of service. So you will have this kind of service life cycle management. In addition, actually, you need to cover service maintenance. One of the important important feature in the service maintenance is service assurance and service diagnostic. And you need to figure out how different model put together to provide the service assurance or service diagnostic. This is something we actually have some example in the later slides. And in addition, you want to support a closed loop network management or service network management. So the model you can leverage or the mechanism you can leverage, for example, model-driven telemetry. You have IETF defined YAM push telemetry mechanism, or you may use GRPC, GMI, whatever. And also, you have model-driven policy model. Actually, there's some technology-specific policy model like ACL, routing policy, queues policy model. And you also can leverage some, we call the ECA model, is kind of imperative policy model. With this ECA model or model-driven policy model and model-driven telemetry model, you can build a closed-loop network management. Another thing actually is important is model layer translation. Actually, you have different layer model. You need to smoothly translate between each other. You may translate between different layer. You may translate in the same level. One example is for translation between different layers, you translate the service level into network level. But there's some challenge actually, because during this translation, you need to figure out where you get these results, how to allocate these results. So simply static translation is not enough actually. For device level translation, actually, you may consider translate the standard model into the private model or native model. Here we show how YAM data model interact with each other, how YAM model can interact with some mechanism. So several examples. The first example is kind of telemetry model work together with network, work with device model. Actually, you can leverage YAM push to subscribe raw data, and you can aggregate this kind of data to the tunnel level, VPN level, and then you can actually so you can benefit from this telemetry performance measurement model to try to keep track of the network performance, and so can provide a better insurance. For example, some cases maybe performance service is downgraded, you can optimize the network. So second example is cross-layer translation. So in a high level, you may translate service level model into network level model, as I mentioned in the model representation slides. And in the lower level, you may decompose the network level into a bunch of the device model. And this also may need to rely on some translation functionality. The third example we are giving actually is policy-driven example. Actually, this actually allow you to delegate a client-generated policy into the device level, allow the device several control. So you say we have separate model actually to do this, and they can support various different action. Actually, one of the action is actually you can trigger some local notification. Also, you can actually to reconfigure some of data object within the device. So another one actually, maybe you have a bunch of YAM data model. You need to put them together and glue them into super device model. Actually, in this way, you actually can, make a data node within each model has a unique XPath. So you can provide a consistent reporting, representation, and configuration. So this is something very powerful we can leverage. So the mechanism developed by the IETF actually is a scale mount. We can leverage this to do that. So we provide several cases. The first case is VPN service delivery. Actually, the model we can using, for example, L3NM. At the service level, we can use L3NM that be presented in a previous topic, and we could translate to each other. So, in the network level, you really, try to solve is how where you get a resource, how to allocate this kind of resource, and also you can decompose L3NM model into BGP model, QoS model, ACL model, and get a network setup, enable the BGP protocol or ACL feature in the device. Another one we show you actually is the service assurance use cases. In this case, actually, we can leverage some loss-bound performance measurement telemetry model. There's two typical examples. One is TIS VN telemetry model that be developed in TIS working group. Another one is VPN performance measurement telemetry model that defined in the BESS working group. We actually can leverage this loss-bound performance measurement model to measure the network performance. So usually you will measure pruning the network performance like latency, bandwidth, and then you can aggregate this into the tunnel level, VPN level, more from the customer perspective. So the operator can use this kind of VPN level policy metric to optimize the network. So in this way, we can provide better service assurance. Another one, actually, we want to emphasize is the ECA approach to build a closed loop network optimization. So ECA, actually, they can generate client script. We can push down this kind of client generated script into the device. So enable the device can self-control, self-management. So in this way, actually, we can to help to do the network reoptimization or provide better service assurance to do the troubleshooting. There's many cases we can cover. So that's all right now. I think still this draft need to improving, especially security section we haven't finished. We'll keep on polishing this document. We'll solicit feedback from the floor. Thank you.
Comments?
Laurent Chavalia. I think in one of your diagrams you present interaction between the service level and network level from the service lifecycle point of view. I find it a bit misleading to have service level operation in the network level, because I mean you don't decommission the service in the network level. You will decommission part of the service that is at this network domain, but the service decommissioning should be in the life cycle at the service level.
Yeah, I think that's good comments. Actually, we also get some offline comments from Telefonica. They think we should consider service verification, service validation during the maybe service creation stage, and we will try to fix this. Yeah, thank you.
And then second comment, which is more on the models interactions. I think the next slide. I think this is good examples, but maybe another way to categorize a bit this kind of interaction, because here the criteria seems to be young models. Maybe if you go for a kind of operations that you typically do between service and network, you will have a set of typical operations, and then you can say which models are involved for typical operation, because otherwise you can have end-to-end like a mesh of interaction between models, and it will be difficult to see, because I mean.
Yeah, that's a very good suggestion. Yeah, we try to categorize this kind of different example. Thank you. Yeah.
Thanks, Chin.
Okay. Thank you. Okay, next one.
Hello, everyone. I'm here to talk about the Young data model for TACUS Plus Young model. And right now, it's a working group draft. And the TACUS Young model is for supporting the TACUS Plus protocol that, configuration from the NetConf Young operation system. And here is the brief background of this Young data model, because existing IETF system model just covers local and radius authentication. But you can see that in the working group, they already doing the TACUS Plus protocol also is in development. So this data model also extends system user authentication method to not only support these two, but also to add another TACUS Plus authentication option. So this is the current tree model. And since last meeting, we just added the session node to reflect the John Hesley's comments, because he suggests to add this session node to reflect that in a one single connection, there could be more sessions involved. And here are the changes since last meeting. The mainly the improvement is that based on John Hesley's comments, can give or clean up of all the text, including introduction one, and also the Young module and design part. And we added TACUS Plus as a normative reference, and we, since Eben Aris proposed us we need to configure system authentication to enable TACUS Plus authentication. So we added TACUS Plus identity to enable it. So there is one remaining issue that is from Eben Aris, that the current system authentication only allows local and radius. So we added the TACUS Plus authentication method to it. But the problem is that a current system defines a mask constraint, that it only allows to verify the radius configuration. So in that way, although we added the TACUS Plus authentication in an identity, but still we cannot use a mask to verify the other parameters of TACUS Plus, like whether we configured servers yet. So this is the only problem. So here I had discussion with Eben. He thought that if I added the identity, then it can be it's valid, so it can be used. The only problem is that the same system gives a very restricted definition. So based on the Young 1.1 definition, the augmentation target node cannot be list. So in that way, we cannot use mask to augment this node. So in that way, mask cannot be added. So in that way, we think this is a remaining issue, but we don't know how to solve it. So the question to the working group is that we just leave it as it. And we propose to add a note to the appendix to see whether like in the next system release must could be removed or be replaced with a new one. So that's a question for this one.
Have you, so one thought to fully brainstorm this out, talk to any of the Yang doctors on what might be another option forward here?
Okay.
I can help
Okay,
broker
okay, thank you.
that.
Okay.
Something else, since you added the normative reference to TACAX, just for you and the working group, so the Rev 16 of that draft was just posted, and the authors are now working to clear all the remaining discusses. So I talked to Ignis. We're hoping that we get that through in the upcoming telechat, and then it moves forward. So just FYI on that, and I'll take the action to see if there's any alternate thing we can do here with the IETF system.
Yes, since it's a cross-model issue, so I think that's the right way. And here, this is the only remaining issue. So if like we resolve this one, so I think we can ready for the working group last call. So
I have a question about the mass statement. So have you already discussed with authors of IETF system about when the next version will be released, such that you could identify if you could add this mass to appendix, and after to collaborate with IETF system authors to include, basically to combine both documents?
Can you state your name?
Dmitry Shity from SFRLTs. Sorry.
okay, I think I can. It's a good suggestion. I will send the email to the NetMode to check what they think about this model and what their plans. Thanks. Okay.
Thanks, Bob.
Okay, next one.
Good morning, everyone. Oh, thank you. Today I'm going to present the in-situ flow information telemetry. This is joint work with FutureWay and several other operators, collaborators. So the message conveyed by this draft is very simple. We are all seeing the emergence of a new type of data plane telemetry technologies. We call them on-pass data telemetry. And operators are very interested in applying this kind of technology, not only in data center and enterprise networks, but also in operator networks. However, to successfully deploy this kind of technology, what kind of pitfalls we want to avoid, and what challenges, requirements we are facing, and also if we want to build a standard-based solution, what standard gaps are there, what are missing, what are available. So it's a good thing to actually formally categorize this kind of technology and classify it, then provide all the information we know so far about the challenges, and propose the possible innovative solutions which can address this kind of challenges. And also, finally, we can point out what are available right now and what are missing. But we also want to clearly state that we don't intend to provide any specific implementation to infer any constraint to the implementation for the components, functions, and also the interface APIs for them. We want to leave them for the real implementers. And also, we think the purpose here is only to inspire such kind of work. So first, we think we already have the two types of passive and active type of OEM technologies. But here we are clearly seeing there's a third type. We can call that hybrid type 3 or unpassed data plane telemetry techniques. And we can also further partition this into 2 different subclasses. One, we can name it passport type, which includes IOM trace mode, IOM E2E, and IFA, hybrid 2-step, and enhanced alternative marking. So you can see the common feature shared by this type of techniques is that you need somehow modify the user packet along the path, or you just do the monitoring or measurement at the end of the path. But the second subclass is called postcard mode, which means you along the packet forwarding path, you don't modify the user traffic anymore. Instead, you just read the instruction carried by the packet, then you generate the postcard data export using independent export packets. So clearly, the example for that IOM direct export mode and the PBT marking based variation. So how we will successfully deploy this kind of technologies? So far, we mainly specify the underlying techniques, what's the packet format is look like, how the nodes will process it. But we haven't considered many other challenges so far. The first one is the performance implications. This kind of processing may actually stress your forwarding plane. You have to consider about the performance, and also the data generated by these technologies may be too vast, and also they can overload the export, the network bandwidth, and also the data collectors. And also, so far we only defined a fixed set of data that can be exposed by the data plane. There's not enough flexibility and extensibility. We want to also change that. And also to actually deploy it, we have to consider various kind of data plane encapsulation protocols. There are some proposals available, for example, for IOM, how to encapsulate it in different type of transport protocols. But first, it's not complete, or some important protocols are left out. And also how we can expand this to support other similar type of technologies. That's not considered. We think we should have a holistic view to support them either. And also there are different tunnels in the carrier network, and we have to consider in different type of tunnels how we can successfully, properly handle this kind of package. And the last challenge is actually about what kind of primitives and models, APIs to support this type of technology. And this not covered in this draft. We just point out what's missing and what's the current status. Hopefully, this can inspire a bunch of new draft to detail about this this kind of requirements. So to address these 3 key challenges, one is the performance, the deployability, and the flexibility. We propose several key components, function components. We can work on them to provide our own innovative solutions. Then we can address these different challenges. The first one is how we can correctly configure the network to only pick the flow and the data we want to really look at, so without stressing the network resource. And secondly, how we can take advantage of the in-network processing capability to reduce the amount of data actually exposed to the data collector. There are many ways to do that. One of them, we can deploy some programmable probes into the system to actually define a good smart filter or some data reduction techniques. For example, we can deploy the events into the system. Then only when the event is triggered, we can start the data exporting. So this is very effective to save the bandwidth and also the processing power and the server side. And we think the encapsulation, the tunnel modes are very important to support. We need to provide standard ways to support those. And finally, we think in one application, maybe just using one underlying technique is not enough. Many times you want to integrate several techniques together, or we can dynamically choose one at one time, and based on the changing of the network conditions, we can switch another one in runtime. So we call that on-demand technique integration. That's also an important component. So here we show the overall high level of this architectural framework. Actually, it should look very familiar to you. It's just like a normal SDN architecture. Basically, the controller will configure all the nodes in one iFIT domain. And then after that, we will get the telemetry data from different nodes to the collector. Then collector, after analyzing this data, it will feed the information to the controller. Then controller can take into consideration this feedback, then adjust its configuration. So you can see, naturally, we will form a closed loop architecture to allow many innovative applications, telemetry applications. For example, the iFIT application will choose the technique to integrate them dynamically and send the smart flow and the data selection to the header node. And all the header node and iFIT nodes will be deployed with dynamic network probes to support the smart data filtering and the data processing and the data export. And also, they will be configured use standard way to encapsulate the packets and go through the different tunnels. And this closed loop will support many different kinds of very interesting applications. So I think I don't have time to talk about them one by one, but if you are interested, you can look at our draft. And in the draft, we describe several very interesting applications enabled by this closed loop architecture. So let's have some discussion. So in the email list, I have already requested the adoption of this draft in the working group, and it triggered a lot of discussions. The majority of them are mainly from the operators. They are very interested in this kind of work and support it. And also there are some feedbacks about, okay, we are not very clear about defining some terms in this draft, and we not very clearly defined the scope of this draft. So in the newer revisions, we fixed that. We gave a formal definition of all terms used in this draft. And also we provide another independent section to talk about the standard gap. So basically we list what are available right now and what are still missing. Hopefully that can trigger more works in the working group. And so here we are soliciting maybe suggestions about new future work, what you expect to see to be added in this draft. And if you are interested in this work and you want to contribute, you are welcome. And also we request for formal working group adoption of this work. So any questions and feedbacks?
Diego Lopez, Telefónica. It's just well, we were talking about this during the happy hour. Is about the terms, using the term closed loop here is a little bit misleading. And closed loop.
Closed loop. Okay.
Yeah. When you talk about, because normally closed loop has about something, or the understanding is about the automatic control. You get some input.
Actually, I already, other people raised this question before, and I already clarified this in the draft. There are two types of closed loop. One is in the automation network, there's a closed control loop. But here, it's not that kind of a control
No, exactly.
loop. Yep.
This is simply that. That it should be clear and probably try to find some kind of other term. I don't know. It's like at the end, it's like the term controller or orchestration or whatever. There are so many different meanings that it would be good to think about.
We believe the future telemetry applications will be highly dynamic. You cannot just fix one.
I'm not arguing about that. I'm arguing about the use of the term closed loop only. It's about trying to find a way of describing that you're not trying to control the network, but to control how you deploy the probes and to control the telemetry and not the network. Closed loop is normally more used to the control of the network.
Yeah, it's just in this iFIT domain. We have a clear defined domain to apply this loop. All the controls only applied to the node in this domain were enabled by to support this iFIT functions. If it's not enabled, then you cannot. It's out of the control domain. Does that answer your question, or
No, I mean, I'm trying. Just please understand me. I'm not saying anything that if you say that you are applying a closed loop using telemetry, looks like you're trying to control the network, and it's something that's. I would ask you to use another term. Simply that.
Yeah, if you have a good other alternative suggestions, we can use that. But right now, I think that's the most proper behavior actually happening in this application. Indeed, it's a dynamic. Take the feedback from network and apply the new policies to change the previous configuration. That's closed loop. I don't know if I like to again offline to find it.
I'm not arguing about what you do. It's about how you name it. Simply that.
Yeah.
Simply that.
Okay.
Well, Feng Qin from China Mobile. Well, you know, right, the mobile network of China Mobile is very big. For example, there are more than 13,000 nodes in Beijing. It is difficult to localize with the existing OEM method, but it is too important for us to localize to the specific fault node. We consider the forwarding performance and how to reduce the data deployed to the controller. We compared and chose the suitable data plan. We also have deployed one iFIT data plan in the network with many winters support. Of course, it turned out to be very great. But only data plan is not enough. We hope there is a framework to achieve a complete and closed loop. Working through for on-pass flow telemetry. I think this framework of this draft is very useful for us, China Mobile. The intent and scope of this draft is very clear. We hope it could be working group document so that the specific solution could be rolled out as soon as possible.
Thank you very much for your comments. Yeah, your issues you raised are exactly we want to cover in this draft. Yeah.
Yeah.
Thank you.
Thank you.
We'll go with Frank and then Adrian.
Okay, Frank Rockners. So I think you're trying to do too much in one document here. If I read through this, there is a bit of a review of what is out there in the industry, kind of an inventory of what we have, of multiple vendor solutions, including standards-based solutions.
Yep.
You have a set of requirements outlined. That might be another document, so second document. And then you're trying to go and start off doing something that looks like a specification. And I think some of the earlier comments that you've seen around nomenclature not being clear, I think this trickles all through the document. You're defining things or you're mentioning things that are not really specified at specification level, i.e. I can go and implement something based on that. You're saying an iFIT node, it's the start of an iFIT domain. What is an iFIT domain? What is an iFIT application? What is an iFIT end node? So all of these things need to be spelled out if you want to be an application, if you want to be a specification. So as I said, like you're doing three things in one document and all of these areas are underspecified. So what I would suggest you doing is focus on one thing at a time and then really focus on closing this particular item and then move on.
So actually, we clearly state the scope of this draft, and we don't give any specification. We just provide a very high-level framework. But to define this high-level framework, we need to spell out the terms we used, so to help you understand what we are talking about. So that's all. And we don't actually have a very ambitious to cover everything, to even talk about detailed implementation. That's not our intention.
Then you don't need anything that is called iFIT node, iFIT
No.
applications.
What we
these
see
things
is
are not
okay.
required.
Yeah, what I say is, right now there are a class of similar technologies, and none of them can address all the issues faced by the operators. That's why we need a high-level framework to consolidate all them in one place. So to allow the operator to dynamically choose one or another, or integrate them together in their application. We want to provide this kind of flexibility. We don't want to stick to just one underlying techniques. That's not. I don't think will be the way to go.
So we're going to cut the mic after you two gentlemen, but we're going to go with Adrian then back there.
Hi, Adrian Farrell, relaying from Jabba from Timothy Carey. He'd like some clarity on the relationship between this document and the network telemetry framework, which has already been adopted.
Oh, okay. So that's why actually in the even higher level is cover different planes, even the control plane telemetry, data plane telemetry, and management plane. But this one is dedicated to the data plane. Also, it's dedicated to a specific class of data plane telemetry techniques. We call that on pass or in situ, whatever. It's basically different from the previous passive and active OEM techniques.
I'm Xie Chongfeng of China Telecom. Only has short comments. I think this work is very important and valuable. So I hope this document can be adopted.
All right, thank you.
Zhu Qing from China Telecom. In our network, we need to know some specific flow or package precisely. I think it's a good solution for us. Thank you.
Yeah, thank you.
So speaking as chair, I've heard and read many of the positive and negative feedback on this. I think there is still some issues to resolve. Myself personally, now speaking individually, I reread this, and while you say that you're setting forth a problem description, at the end you say we solve some of these challenges. And I kind of sympathize with Frank in that the document does feel a little schizophrenic at times. Like you want the problem statement to be defined, but you also want to try and specify solutions to it. And I would now back as chair say that I think we have to, in order to move this work forward, there has to be some very specific clarity and agreement and consensus from the working group that this document is well scoped and meets a well-defined set of requirements that people tend to agree to or overwhelmingly agree to. And I think what we've heard here is there's still some challenges in finding that clarity.
Yeah, so I need to clarify that we don't intend to provide solutions. We don't either claim we can solve this problem. We just provide potential opportunities by introduce several useful components into the framework. Based on our previous POC work, and we already show the great potential about that. Then that's why we want to document the challenges and share our experience, and also show from standard perspective what's the gaps there. So that's our intention for this draft.
Yeah, so you said you had another version coming. I would say to the gentleman from Telefonica, if you could comment on list, I'm going to make another comment on list. Frank as well. Let's see if we can't sort those things out. If we're going to move this forward, we need to address some of those points. I think they're critical. And also what Tim was saying, maybe it's not clear enough how this differs from NTF. So I would say we need to address some of those before we can once again consider moving forward.
Okay.
Can we ask the interest about the working group? I want to know the consensus of the interest on this draft, and how many of you have read this document? Please raise your hand. Okay. Then, how many of you think this work is useful and would like to work on this? Would like the working group to work on this draft? Please raise your hand. Okay.
Still,
Around 20. Oh, thanks. Around 20.
Yeah.
And okay, next one.
you might just want to hold it.
My name is Dmitry Shitty, SFR LTs, and today I would like to present the young data model for the UCP management. So there is a classical approach that is followed by the ISPs nowadays. This is using multiple hardware appliances on the customer premises equipment that are interconnected between each other to provide the service. But to perform the installation and configuration equipment, you have to send, ISP have to send the technician on the site to perform the configuration of the topology and of the interior service. This is the first point that the draft addresses. The second point that each equipment needs to be shipped and it occupies the space in the rack. The third point that if there is some modification of the topology, the technician should be sent to the customer premises equipment of customer premises to perform the modification of this topology. And here we try to provide a UCP approach that is addressing these issues. So because the UCP is allowing us to virtualize the network appliances that are hardware to perform the possibility to have this hardware as virtualized one, as virtual network functions that are interconnected between each other. This is the first point that is trying to address. The second point that is trying to address the draft is that if you need to specify the day zero configuration bootstrap of the equipment, it could be easily changed in the UCP. And when it changed, the hardware appliance should be de-instantiated and instantiated again. So the UCP is trying to approach the discussed points that were highlighted by this slide. The second thing that we, in the draft, we're trying to address that each supplier has its own netconfig interface that is managing the UCP. The UCP includes 3 layers. The first layer is hardware layer. The second layer is virtualization layer, NFVS, Network Function Virtualization Infrastructure Software. And the third one is VNF layer. So to manage the UCP, explicitly the second layer, NFVS, there are different YAM models used for each supplier. And this draft tries to introduce, you could see on this slide on the bottom, an example of the UCP infrastructure that and NFVS that you could configure via a netconfig interface. And the draft is addressing the draft is proposing the YAM model that is unique for all of the suppliers. So basically with this YAM model, you could manage the UCP explicitly, the LibVirt, quick emulator, so the VNFs that inside, and you also could manage the virtual switch or vector packet processor inside of the UCP. So basically, this model is kind of unique for, should be unique for different kind of suppliers, and it could be placed in network orchestrator or service orchestrator. So basically, this slide presents the model itself on the right, and you could. We have some questions to the working group regarding the improvement of the document. For example, do we need to include some specific details about this type? For example, IDE, VRTO, specific options, because we could some virtual machines require specification of this. So the question, should it be agnostic in the service in the Python or Java logic, or should it be a part of the YAM model? The second thing that we would like to address, it's do you need some augmentation statement on the top of the model? Because if you want to include it to the service tree or network modeling tree, we would like to we need the YAM augmentation model in this YAM model. And another question is about the CPU pinning. Well, sometimes we want to VNF to not intersect between each other, so we need to assign one core to one VNF, one virtual core keeper threading, or physical core, in this case, two virtual cores, to the specific VNF, such that to have the CPU pinning and the kind of isolation between the VNFs. Thank you. So could you please suggest some questions or suggestions about how we could improve the draft?
Hi, Dan Bogdanovic. How is this different from the RFC 8530, which is the YAM model for logical network elements?
So, in this this model introduces the day zero configuration that is specifically allowing us for the network element to have the possibility to specify the variable and the variable and the value to this variable that you would like to put in the series, because it's like kind of the bootstrap that you are putting to the VNF. You could substitute some variables from this bootstrap with some values. It's the first thing. The second thing that it includes the virtual network functions in description inside of the model.
Can I ask you, are you familiar with the RFC 8530?
It would be nice if you could suggest some
I'm just
general
asking
points.
if you're familiar with it or not. It's called like YAM data, like the YAM data model for logical network elements. You can say yes or no. There's no wrong answer there.
So the point that I could read it, but I'm not sure that I could answer that I remember it. The name.
from Huawei. Actually, in T is working with there's a T topology, service-aware topology model. Actually, maybe relevant to your draft. Maybe you should take a look at that. There's some overlapping.
So thank you for the suggestion. Actually, there's new version is coming, and we included the YAM model to the TE. So we have networks, TE, and after we use the service function aware topology to that is a draft from TIAS, and we also try to we worked during some time on it, and we try to combine together different RFCs and drafts that are provided by the IETF to achieve the goal. So the basic point that the T is used in the next version. So we augment the T3.
Second comment is seems there's some other work in SANFA. So SANFA may develop some YAM data model related to the NFA, VNF. So you also need to take a look at how do you address this kind of overlapping.
Okay, yes, indeed, there's some work exists at C, but the idea here is that we're trying to integrate not explicitly with this model, the next model in the new draft that is coming. If you are interested, you could come and we could discuss. We have this model in our notebook, so it's openly available. So the idea is here that there is some work at ETSI, and we have some structure at IETF that we are developing. So the point is that it's not, maybe it could try to solve similar problem, but the thing here is that what we are trying to address is to develop the IETF young structure. Does it sound good for you, or?
Yeah, just to think whether there's some agreement between ETSI and NFA. Yeah, maybe it's too early to talk about that. I will take a look at your proposal and see how it forward.
So the idea is that in the next version of the draft, we are kind of not creating everything from the scratch. It's more like reusing of the existing RFC and drafts. If you want, I could take the notebook and give you some specific details after the session, or right now. It depends on your desire. So basically, the idea here is that we are not redefining the existing stuff. We're trying to use, not explicitly in this model, in the next version of the model, we try to use what was defined already by the IETF.
Just a question for clarification that you are giving. Could you go to the previous slide? Yes, this one. I'd like to check whether your model is used for like the controller northbound or actuator northbound, because like the previous one, the L3NM, they are defining the network modeling. So I'm just to check with you whether yours one is a service, like customer-facing service model, or network, like network model.
Thank you. This is a good suggestion. I think that we just recently saw the draft about L3NM and L3SM, and maybe this draft that we are presenting, it could be addressed by the network model. This could be type of the networking modeling. Yes.
Yeah, I think this like relates to the Dean's comments, like L3NM. I think they are augmenting the network topology model to do the L3 VPN 1. So I suggest you can do the similar work.
Okay. I think in the next version of the draft, we will have this. Basically, we will have the RFC that is network. After we have T, and we augment T with specific service-aware topology, and we add some other RFCs to add the configuration to the data configuration, and for the image booting for the UCP.
So sorry, we're going to have to, Rob and Adrian, can you take the comments to the list? We're running short on time at this point.
Sure, this is a Jabber comment. But,
yep, we'll record it in the minutes. Thanks. Thank you.
Thank you.
All right. So I'm Andrew Gray, and I'm here to talk about a draft idea that we started circling a little bit at the last IETF, kind of put a little meat on it. So we're kind of opening it up for wider audience at 106 here and trying to get some more feedback and input on it. Right now it's called sampled streaming. So as an operator, I've got a problem coming up, and I can see this train coming at me from a little whiles away. I have a lot of tooling right now that takes actual packet data. It's sampling it at 1 in 1,000 or 1 in 2,000. I have dedicated inline appliances doing this, or sometimes I'm doing this on box. As my link speeds grow, every single iteration of that, I have to replace that hardware. And this seems kind of silly when I have a giant router that's sitting there with hardware on board that's perfectly capable of replicating packets for me. Previous arguments against this had been, oh, you know, compute's expensive. I've got so much virtualized compute right now. I've got gobs and gobs of compute. That's not really my problem. I need to get the data off the box. And a lot of the existing methods today use on-box capabilities, but they either have control plane punts, and as I start looking at higher speed cards, where I'm starting doing 14.4 tera, 28 tera on a line card, punting to the control plane is not feasible. I'm not going to be able to get a sampling rate anywhere close to where I want. We're hearing 1 in 20,000, might even be optimistic from that. So I need to be able to control this sampling or this packet replication or span or whatever you want to call it. I want to be able to do different variable sampling rates, and I want to be able to filter this on ports or layer 3 information or what have you. The other kind of nifty thing I would like to be able to do is be able to grab both traffic that I'm forwarding and traffic that I'm dropping. So inside the draft itself, there's a little bit of nomenclature we just put in there just to try and keep things sane. The client is basically the box doing the configuration work. The replicator, you can, for most of our purposes, think the main router, the control plane. The point is usually easiest to be thought of as an ASIC. And the receiver is whatever device off in my data center cloud that I'm sending all this sampled traffic to. So my must-haves that I want as an operator from this is I need this to be extremely light on my on-box CPU. The data planes are scaling incredibly high, incredibly quickly, but on-box control plane and on-box CPU aren't. I cannot be sending terabits of traffic to my on-box CPU. It will melt down. So I need something that can be handled strictly on the data plane. I want to avoid ASIC recirculation or anything that causes me to lose performance on this box because, again, I'm running these boxes pretty hot. I don't want to have to sit here and worry about it. And most importantly, I need one standard method to cover everything. Routers, ideally servers, anything that's really passing traffic should be able to handle the same thing. Nice to haves. As a packet goes through a box, the ASIC certainly knows more information about it than just the bits and bytes of the packet itself. It has things like what port did it come in on, when precisely timestamp-wise did that packet start arriving, what is my intended disposition of that packet, am I going to forward it, am I going to drop it, if I'm going to queue it, what am I actually doing with it. Generally, internally, ASICs will know this information and they'll have it in various bits in different places in the cells that it's using to forward traffic with. I'd like to be able to get that. I'd like to be able to pull that off box so I can do analytics and everything else on it. The other point I say on here is, being able to see what traffic I'm dropping at that box would be very useful. Are my QoS policies working right? Are my filters working right? Being able to actually pull that traffic off before the box drops it would be a very nice to have. So we've ran this draft around a few different people. I always seem to get the same set of questions right away, so kind of heading some of this off at the pass. One question comes up fairly often is why not use an IP fix extension or something along those lines? The bullet points up here kind of talk about the big ones of that, but the main thing is I want the raw packets and I want that ASIC meta information come off of it. I need to be able to set the sampling rate potentially as low as 1-to-1. One of the use cases that we mentioned in the draft is having, for example, a security box that's watching all my incoming traffic. Maybe it pulls it off at 1 in 1,000. It sees something strange, a DDoS or a microflow DDoS or whatever you want to call it, and it can add in an additional rule that says, hey, I want to see this traffic and I want to see it at 1-to-1, for example. And a lot of these things are CPU driven. They're either control plane punts or you have to do a lot of work on the chip or you have to do it recirculations to implement. Inside the specification or inside the draft, there's actually a little bit of negotiation that goes on. And the actual format of the data that comes off towards the receiver here, that green arrow, is actually determined entirely dynamically in the protocol. It is not set. There is no set packet format. Instead, what's defined is basically a way to communicate. This is the structure of the data I'll be receiving. So for example, it can say, hey, I've got 6 bits at the header. It'll tell you what the input ports are. And by the way, here's the mapping. A value of 8 here will be port 0 or what have you. All of that is handled in the control plane negotiation up there between the replicator and the client. The point doesn't need to do any data conversion on its own. It just copies, replicates, throws a header on it, and gets it off the box. So That's the main reason behind not having a fixed format, having this negotiated format. Having an ASIC try and do anything fancy with bit manipulation almost inevitably results in slowing down the how much it can forward through. The specification is written to be reasonably future-proof, and we're looking for additional inputs or what else we can add in there. But if worse comes to worse, there's even a generic padding, just, hey, this is 13 bits of internal garbage that's going to be sitting on the wire. Ignore it, but having the ASIC actually sit there and try and reprocess that packet to take that 13 bits out is worth less to me than just being able to shunt it off at my compute capability. So next steps, we're at a -02 right now, which kind of reworked a couple things. There's actually now a mechanism for having the replicator present different options back to the client. So the client can say, hey, I want this. The replicator can say, okay, I can give you exactly that, but you're going to take a research penalty. Or I can give you this that's kind of close without a penalty. We've had a lot of good feedback from a few different operators and a couple different hardware providers about it. So we are continuing to work on it and just looking for more interest or input or what have you from the community at large.
We probably have time for 2 comments, and then the rest will have to go to the list.
Maybe I have one, Frank Bruckners. So I have a lot of sympathy for the draft, and you said that, well, you have a load of questions that you typically get, and I would really definitely suggest that you address them in the draft, right? So if you scan through the draft, you don't even find PSAM mentioned. So I would have expected that you compare it to 5476 and say, well, this is what we're doing differently. And so I would well, you can have that example that you have in section 4, where you have ACT fields, that's forwarding status with IPFix, right? So you have incoming port, that's ingress interface. You have the timestamp field, which is your export time in IPFix. So all these fields are defined. We should have at least, if you're comparing, this is how we would do it with IPFix and PSAM, and this is how we do it, and hence we're more compact, and that's what we're adding on. Let's do that in the draft, right? So that we are clear on what the delta is that we're trying to solve, as opposed to right now, it seems like something new. Well, it's a delta, it's a little bit of a delta of what we have. And let's make that explicit.
Okay, that's good feedback. One thing I'll point out is a lot of people will look in the draft and see, I have a couple examples of what the resulting packet header will be. Those are purely just examples. They're not normative in any way, shape, or form. Thank you.
Dan Bogdanovic, you were mentioning performance. Yes. And I would have a question on capacity, and indirectly you're mentioning capacity. If you want to do any data plane packet, collection, mirroring, you always have a choice. There's only so much, things on the ASIC that you can do with it.
Right.
And in a way, what you're asking for is sort of you cannot have both. You can either have more telemetry from the data plane, or you have more packet forwarding. Which one do you want?
So, outstanding question. That's actually one of the main things. So the draft does address this a little bit in saying, if you enable this option, you're going to take this amount of performance penalty to do so. So that's the reason why that option was in there. In terms of what I want from an operator perspective, I want the data off the box. I'd like to do it for free, but that's incredibly optimistic. Now, I will say, generally speaking, and the reason I pulled this slide back up, the interfaces that are being used for the normal traffic flow are almost certainly not going to be the interfaces I use to send the traffic off, at least in our use case.
Yes.
So having the ASIC do its normal processing and also doing effectively a packet replication going somewhere else, that's kind of something ASICs can do fairly well, usually. This is just saying, hey, copy the additional metadata and throw UDP header on the front of it. So understood, it is a concern, but to your point, sacrifices have to be made sometimes.
And the other part is also when you're saying, we would like to get this additional data from it, you can get it additional data, but again, it's coming at a cost.
So
it's all about, everything comes there with a cost, and there has been, a long-standing issue with that. Many people was, we would like, to have this information from it. Yeah, sure, you can have it, but this is what it costs you. And then they're starting to rethink the issue.
So the way the draft is written, the replicator is offering what it can provide you essentially for free. So for example, if it knows its internal format has this additional information, that's all it's describing. It's saying, here's the additional information that's available. We're not really asking for it to do additional work.
So my main concern is what you're saying for free. There isn't a freelance.
I'm being a little ironic / sarcastic there. Yes.
So we're gonna have to cut the mic. We need to take the additional comments to the list. We are very tight on time at this point. You're the AD and it's cutting into your time, so.
Right. Given Ignas Bogdanas, given the interest in this topic, and while we are here, Andrew, please organize a side meeting today, tomorrow, Friday. Announce that to the community and have this discussion there. This appears to be needed.
Yeah, so it's gone out on the mailing list a couple times, but generally I'll say, hey, here's a new draft out on the mailing list. Here's a little bit about it. So the intention is to, do another announcement out there on the post site. Hey, here's the draft. Let's talk about it.
I think what Ignas is saying is we have opportunities to do side meetings here while in Singapore. So if you can schedule one, there seems to be some interest in pulling that together in face-to-face.
Oh, okay. Yeah, absolutely. So I'll send out a message asking for that too. Thank you.
Thanks. Okay, Frank, 5 minutes.
It's going to be 3 because I'm freezing. What a nice and warm room. So, thank you. This is a new draft that we just recently published to fill an old gap. So we have quite a few IOEM drafts in flight, and they're touching on multiple aspects there. It started off specifying the data fields. We have drafts that cover operations. We have a Yang model. We have a draft on data export. We have multiple drafts on the various encapsulations for the various protocols that IOM lives in, but we never had one draft that pulled it all together. Well, we have one now. I think that's the announcement that I want to make, because many people have been asking me, how does it all fit together? Kind of give me an inventory of what is out there and tell me, how can I go get it deployed? What do I need to go and consider if I move from the various specifications into something that is real life and working? What do I need to go and take into account? So discuss how I use namespaces, how I use layering, how the various trace option types are used. Why do we have different trace option formats? Something that is maybe better for a hardware implementation, something that is maybe better for a software implementation. We're discussing all of that in that particular draft. We already received a bunch of input saying, well, I want this to be better specified. Barak, who had to leave yesterday, said, well, I'm going to go and give you a paragraph on active measurements and probe packets. We need to go and expand on what a particular layer is and how you're going to go and supposed to use the layer above and beyond what we have in the draft. So there's a couple of things. We need to go and expand on certain ANCAPs that are not really fleshed out as part of the original drafts, like with the GRE. How do you use it? Because there's multiple ways on how you're going to go use it. So I think we have a home for that now. That's it. Any thoughts? Anything? Is that useful as a document? Because if it's useful as a document, I heard so far, then, well, I'm hoping that we can go and make it a working group document in the not too far future. That's one.
Jeff, I think it is very useful. It puts all the different work in single document, and especially for people who come into this area. Now, it's really complex to understand what's been going on for the last 5 years, starting with INT and Barefoot and everything that came after. So it's really a good document, and I would support progress.
Okay, thank you. One more.
Rajiv Asadi, Cisco. This is really useful. One thing I might suggest you to consider is to add, maybe expand on some recommendation. Like there's so many things that, it's like a recipe, but how to cook something out of it. If there's a section where you could give some sort of recommendation, that would be immensely useful.
Okay, thank you.
Developers, no, I found the document quite useful because navigating all the IOM at the end becomes really challenging if you're not part of the people writing the documents and you're trying to apply it.
I would agree to that, right?
Exactly. Even if you're writing them, right?
Correct.
No, but probably, I mean, this idea of the strict recommendations probably is going to go a little bit too far. I would leave this open till we have more actual experience in the deployment. We can make an amendment, a new one, etc. Simply because of the accumulation of experience. That is something that we will require in the coming future, I guess.
Makes sense.
Jeff again. So given its really applicability, I think I would like to ask you to present in routing next ATF, if possible. Asking us routing working group chair.
Yeah, good.
Thank you, Frank.
Thank you.
And last up, Tito.
Hello everyone, I'm Thiru. I'll be presenting an update to the MUD TLS profiles for I'll be presenting an update to the MUD TLS profiles for IoT devices. This first version of the draft was presented at okay, thanks. Yeah, the first version of this draft was presented at the last IETF. We made significant changes to the draft after that, and I'll be presenting an update to this draft. We'll go over a quick review of recap of what this draft talks about and the solution overview and our observations with IoT devices. So what we have been doing for the past few months is basically collecting a TLS profile from various malware families from our McAfee labs. And what we had identified was there were significant differences between benign flows and malware flows. I've listed some of them, basically where the certificates from malware flows had a mismatch between SNI and DNS names. They were using self-signed certificates, were using expired certificates. Many of the malware families were using old cipher suits, and they had very low diversity of TLS extensions, and there was quite a bit of differences between the extensions that were used by IoT devices versus what was used by malware. And we saw DGA names used by many of the malware that were probably running on Tor or other communication channels that were supposed to hide their communication patterns. And we saw many of the IoT devices were not validating the server certificates and were easily susceptible to man-in-the-middle attacks. So what we identified was that MUD as such is very useful to basically protect various IoT devices, but it was not that useful for IoT devices which had very broad communication patterns, especially those IoT devices which could learn new skill, and that new skill would change the server and other devices it would communicate with. And we also saw various IoT devices were vulnerable to TLS-based attacks, especially the man-in-the-middle attacks. So based on that, we have been profiling various IoT devices in our lab and from the production. And what we had identified was that the TLS profile for IoT devices based on type of the device, manufacturer, and make and model is quite different from malware flows. And the TLS profile did not change for most of these devices, even after learning new skills. And the TLS profile was fixed set for these IoT devices. And then we also got our TLS profile parameters for thousands of malware flows from various malware families. So based on that, we created a whitelist of observable DTLS profile parameters. And this is an extension to the MUD, and it's an Yang model that we created. I won't go through the Yang model due to lack of time, but I'll just share a few of the data that we have. We'll publish a paper with all the data that we have got for various types of IoT devices. But for example, if you see here, the number of extensions offered for malware was quite different from what EchoShow had for benign flows. We could also see a difference in the number of extension types used by benign and malware flows. I think the graph has gone bad. Right, sorry for that. Benign flows were using grease values, but we did not observe any of the malware families were using grease values. There was quite a bit of difference in the supported groups that were used. Sorry, the graph has gone bad again. This was interesting that there were some malwares which were using APK-based certificates, but many of the malwares were using self-signed certificates. There was quite a bit differences in the signature algorithms, cipher suits, and for Google Home, it was quite astonishing that there was quite a bit of differences in the cipher suits that were picked by Google Home versus what was picked by malware flows. And the protocol versions was quite different, that malware was using TLS 1.0, whereas we could see Google Home was using TLS 1.3. And based on this observation, the conclusion that we could at least initially draw is that malwares cannot mimic the DTLS profiles of several hundreds of IoT devices and cannot keep up with the updates to the DTLS profile. So we thought it's going to be really useful to have a profile for IoT devices that can be used to permit intended DTLS behavior and block malicious DTLS behavior. So what we are looking for is more feedback from the working group and collaboration to profile IoT devices. And if there is interest in the working group, then consider for working group production.
Elliot, we have like 0 time for comments. Can you take that to the list? Thank you. And we will follow up. I would like to see more discussion about this on the list. So,
yeah, thank you.
Thank you. With that, passing over to Warren and Ignis. Yep, I already have.
Benoit's.
Benoit slides?
Yeah.
You had your chair slides here.
Yeah.
Benoit. Okay. And there you go.
So in the interest of time, I think we're going to skip our chair slides. There's nothing important in them, is there? Nah.
I don't believe so. This is Benoit.
And we'll have Mr. Benoit. Yeah. I think also due to lack of time, we're going to have a very short ops area open mic at the end, or maybe not, and people can just send email to the list. I would like to make sure whoever's doing Jabber scribing / minutes will continue to. It's great. Okay. You know this thing stand in the box.
All right. So I want to present our service assurance for intent-based networking. So first of all, it's an architecture, but also it's a set of APIs with a Yang module. It's the first time I'm presenting. I receive also already some feedback. That's why there's like, these are non-0.0 version of the drafts. All right. So what are the issues you're trying to solve? First of all, facts. A service being configured doesn't mean it works correctly. We've been focusing on netconf and restconf and Yang. That part starts to be okay. Now, the second fact, we have way too much data with telemetry, data as opposed to information. Now, what are the issues trying to solve is that when a service degrades, we would like to understand what the fault is. What are the symptoms, or even better, if we know it, what is the root cause in the network? Now, we also want to understand the reverse. If I know a component is failing, like an optic, for example, then I would like to know which services are impacted. And in the end, what we want to do is how to solve the closed loop, because we'd like to get human out of this. Now, the end goal is self-whatever. Healing, driving, intent-based networking. The thing with intent is that, yeah, this top-down approach, declarative way, is a nice concept, right? We tried with SUPA, first with ECA. Now, it works mainly with greenfield deployment, right? And we have to solve it differently. So do we want to take questions now or at the end, knowing that we're... Can we take the question at the end to make sure I go through for a slide? Thank you, Dan. So this architecture is about service assurance for intent-based networking. We want to decompose a bigger problem with the service assurance into smaller components. And we want to assure those smaller components one by one to complement them with active probing, right? The active probing is great end-to-end, but it's like a black box of the network. Yes, there is something happening. We want to know what's happening crystal box, right? Exactly what the issue is. Now, a couple of concepts that I want to bring here. And again, I will be quick because there are concepts, read the draft, but we want to decompose a service instance. And I take a very simple one, like a tunnel there, into sub-services instances. A tunnel depends on what? The source tunnel interface, destination tunnel interfaces. And then those depend on the physical interface. That depends on the device, right? I also need to have IP connectivity. That depends on the control plane. So if you could assure every single part of those sub-service instances independently,
then we would know what we could infer the score, the health score of the device. And that's exactly what we want to do here. And we could have the symptoms for each of these subservice instances. And we would be able to know what? Well, first of all, okay, no, let me take a step back here. So if I know that my device is unhealthy, I could bubble up the health score up to the services that are impacted. Now, there are two ways to see this, dependencies, right? Either this is what I call an impacting dependency. If my interface is down, obviously my tunnel will be broken, right? If my tunnel interface is down, same thing. These are impacting dependencies. But you've got also like informal dependency, because most of the time it's more difficult to find a symptom at the root cause, right? If I've got an ECMP there, my ECMP is not healthy, it's in balance. Now, I want to receive this as an information that maybe my service is impacted. It depends which path I'm taking, right? Maybe. So this is the distinction between informational and impacting dependencies. So far, what do we know? We know that when a service degrades, we know where the fault is because we've got this assurance graph. We know where it's not because it's healthy, and we know where it is with the symptoms or the root cause. And we know the reverse, because if we got the tree in one direction, because it's a gigantic tree for all services, we know which services are impacted, which is also very important for customers. I have to solve that issue first. Now, the architecture. We take from the service configuration orchestrator, we extract the service type and IDs of what we want to configure. This is the start of the intent of that service. From there, we go to this orchestrator there that will create the assurance tree. And the assurance tree goes into what's called a SANE agent there that will tell, actually, to make sure I get the interface health, I need to go on the device for that interface, get a set of metrics, and compute the health. And that health score, along with all the symptoms, would be sent through telemetry. And this is, I believe, the way to solve the closed-loop automation, because maybe we'll be able to tell that interface is behaving badly, that ECMP has got an issue, and we could either reconfigure or optimize. But we know exactly what to reconfigure and not the entire service. Now, it's a flexible architecture, right? I put boxes in there. I could have this config orchestrator and this assurance orchestrator together. Same thing like this SANE agent could be outside of the box, the router, or in the router itself. But more importantly, this architecture should be open. Why? Because there are not many operators having a single vendor, right? So if you want this to work, it should be open in terms of API. How? For me, an API is a Yang model. A Yang model that we could augment. So what is open actually in there? These are the two arrows over there. The ability to read and configure this assurance tree whenever you got the service. And the ability to stream the health status, so the score and the symptoms. This is what you got in the Yang module there. What this work is not about, it's not about standardizing yet an orchestrator. Too difficult. It's not about standardizing the SANE agent or telling exactly what expression are needed to discover the health score of ECMP, right? We could do some in the IETF, like interface, etc. Great, but not everything. Now, typically, I put this on a purpose in a very small font because every single Yang 3 IC are unreadable, but this is like a huge screen, so actually could. What is more interesting is that I just want to show in blue what we could be doing with that Yang module. We could read and create the assurance tree. Right, remember the tunnel and what it depends on. As a very simple example, we could create it, we could augment it, right? The second thing we could do is read or actually push, stream all the health score with the symptoms, with the health score weight telling this symptom is pretty important, What else? We could tell what are the parameters of a subservice. If I got a device health, a typical parameter is the device ID. If I'm doing the interface health, this is this interface on that device, etc. But what we could do as well there is that we could augment this. We could create more of those subservices in order to discover the health. And I even give in the document a way to augment it, right? If you got something specific or proprietary, like a device health, for example, is very specific to a platform, an OS, a vendor. So you could have like your own subservice type. So, okay, maybe I was quick on the concepts, on the architecture, but this is what I wanted to do to give you the opportunity to read the draft, to comment. So is this something like a valid problem? And so far the feedback from operator is yes. And is this something we should be solving for the industry and here? So feedback, flame, tomatoes, up to you.
Oh, a little bit of everything, Dejan Bogdanovic.
Yes, I know you.
So this is a problem to solve. Most of the operators today still use radius accounting records for the service assurance. They're saying, oh, you know what, service is up if we start receiving accounting records. Looking at what they were using there, you know, essentially what metadata is in there, that would be a good thing to try to model according to that, because they are different ways, you know, what they're doing there, and learning some of that would be useful. And we will know really what they're looking at, because when you say service assurance, it's a really, really wide term. Number two,
it is, and that's why there is something I haven't mentioned, is that even if I would like to get Yang models for everything, sometimes we don't have that. That's why there is a notion of a metric engine where we're getting one time from CLI, one time from SNMP, one time from Yang, etc. And we have to map it. Yes.
I know, but you went there into some specifics, which I'm not 100% sure that, you know, that's a good way in, you know, in the model. So maybe doing like a pseudo model with a high level, not going down. More of an information model versus a data model would be a more useful start.
This is what I just mentioned. I'm doing an information model of all the metrics to look at.
Yeah. So then with the architecture, I have some problems because I consider that architecture a little bit too complicated. And this is a separate discussion. And last would be, there's difference between autonomic system and intent-driven networks. These are two separate terms, and you mangled them up at the beginning of your presentation. So I would like to keep that this distinction clean, because you can have an intent-based network that is not autonomic.
Okay, fair enough. One more thing on your previous point. Something I learned at being an AD is that I was beaten by OpenConfig to have running code. So before doing this here, we spent time, a lot of time doing a POC, and it actually works.
And just to note, we've only got about 4 minutes, so we're going to cut the mic line, and also please keep comments short.
Jeff, so you just kind of explained what I do on a daily basis. So number of observations. One is the intent consumption. We still don't know how to program the system. There are a number of workflows and products, but they are not industry standards. Everybody does something. So it would be very useful to focus on that. Number two, expectation generation. It's not explained in the draft, and this is one of the most complex things. You need to generate expectations with regards to your operational state as you define the service, not afterwards. I mean, nobody cares about tunnel. What you care about whether service A can reach service B, and if it's over the tunnel, so be it. But expectation for it to be up should be generated within. Number three is normalization layer, which is one of the most complex things. It's really what Dean referred to, high-level abstracted model. I get data over streaming telemetry, CLI, all kind of APIs.
Agreed.
How do you model all the stuff in coherent way? I would say those three are the most significant problems. And if you could focus on them, that would be extremely useful.
I agree. That's why I started by opening just the APIs for now.
Robin from Huawei. I two comments. The first comment is I'm not sure I understand is right, but I see is here more layers is introduced. So I have a little concern about this work, about the convergence of the young model work in IETF. So I think we already do a lot of layers. So I don't think we try to make more layers. So this is the first concern. The second one, I think for the intent-based work, in fact, for the past years, we also do a lot of work. From our point of view, I think the most the challenge is not the architecture, and also this the model. I think the most important is the infrastructure. Definitely, you need to provide more mechanism to collect the network status as much as possible.
Thank you. The second point, I fully agree with that.
Rajiv, sorry, Cisco. So first, yeah, it is very useful. Second, if you think about from the perspective of configuring, there has not been a concerted effort, well, in the industry per se, not just in the IETF, to actually be able to model the assurance aspect and create that hierarchy. Now, things can, service assurance is such a big enchilada. It means a lot of things to a lot of people. It might be useful to actually contain and define what that really means. Now, many of us might be thinking about network service assurance. Some might be thinking about just security assurance, and the list would go on. Now, the concept that what I gleaned from the slide could equally apply in any of those specific type of services. But I think what's really useful is to figure out the hierarchy. A service depends on A, B, C, A depends on X, Y, Z, Z depends on, and so on and so forth. So that hierarchy and modeling that hierarchy is, they are extremely useful. Few things in there, physical versus logical awareness would be very key to reflect. At the end, that's what it really turns down to. Yes, the architectural diagram is too simplistic. We know in reality that's the utmost complex beast out there in production networks. We may have to find a common ground, what is somewhat not too complex and not too simplistic, and reflect that. So thank you.
Fully understood, and that's why the API is there to augment those subservices types, to not do physical only. It's a very basic example here. Alex.
Okay, Alex Clem. I have two comments. One thing is, I think I see two problems actually that are there, which you may actually want to separate. One thing is actually the service assurance itself, basically the service monitoring. I'm not exactly sure where you call it intent compliance, but it's really basically service, basically monitoring and assuring the service assurance for the service, I guess. That's one aspect. The second aspect is the dependency graph that you're doing for the model-driven reasoning. And I think that is something that you could almost basically separate out from that, because model-driven reasoning and basically dependency graphs is one technique to address that, and you could use this not just for services, but for other dependencies in network and topology as well. And that's, of course, a separate, because there are other issues, of course, with this dependency graph, but I think there are two separate problems. Almost.
Thank you, Alex.
Yeah.
Thanks for the feedback.
Wasn't sure if you wanted to ask. Wasn't sure if you wanted to ask them or wanted to just read more. Great. So we have -2 minutes for open mic. If anybody's got anything really pressing, I guess go to the mic. Otherwise, come and shout at us directly. Thank you very much, everyone. Oh, blue sheets. Who's got the blue sheets?
Who has the second blue sheet?
Who has not signed a
over
blue
there.
sheet?
Right.
There is a blue sheet over there. Thank you.